It's possible to determine relative basicity by looking at the pKa of the conjugate acid. So for instance, if you are wanting to compare chloride to the deprotonated ethane molecule or ion, you could look at their pKa's of their conjugate acids, which are over here to the left. And the pKa of hydrochloric acid is -7. It's a strong acid, leads to a very stable and unreactive chloride ion. And then on the other hand, we have ethane with a really high pKa. And so that translates into an equilibrium constant of like 10 to the -50. So really, it's not going to lose a proton. And the deprotonated ion, the anion, is then really unstable. It would like its proton back, and so it's a strong base. So in general, the weak bases have strong conjugate acids, and the strong bases have the weak conjugate acids. So weak bases have conjugate acids with lower pKa values. So we can use that information in a problem like 3.8, where you're given a molecule with 3 different basic sites. Each of these nitrogens has a lone pair, and the question is, what is the relative basicity of each of these nitrogens? And so you're given the conjugate acid pKa data. And remember, the conjugate acid that has the highest value will lead to a base that is most basic. So we want to kind of match up the conjugate acids to the bases in the molecule above. So this nitrogen up here is not bonded to any double bonds. It's just a sp3 hybridized carbon next door. It's got 2 hydrogens on it. So that's most similar to the nitrogen compound, the ammonium on the left. So let's just connect those. Oops. Maybe I can connect those better. There we go. Okay, so that one looks a lot like that. Then we have the nitrogen, this sp3 hybridized nitrogen that's bonded to an aromatic ring. That looks a lot like this nitrogen on the right. And so the nitrogen over here that's part of the aromatic ring, that's seen over here on the left. So now I have to kind of cross my lines there. All right, so there we go. Since the conjugate acid here has the highest pKa value, it's going to lead to the strongest base, whereas the pKa of the conjugate acid over here on the left, which is the lowest value, will lead to the weakest base. And that's the same as the rule that we saw here.